Today we are going to cover an overview of blockchain. We'll have an introduction to blockchain and its origin, how it started, what it is all about. We'll go through why blockchain is so crucial, and what are the objectives that it meets in the today's challenging technology landscape, right? Why it's being so much buzzed about altogether. We'll also look at how blockchain differentiates from traditional databases, because it's also have been misinterpreted that blockchain is probably a global database, nothing more than that. So we also have a quick peek as to why it is different, or what exactly is differentiator for it from a typical database altogether. Brief on what is distributed ledger, or why DLT, distributed ledger technology, is being so buzzed about, right? We'll also go through a transaction of the building blocks or ecosystem of blockchain. What is the structure or typical blockchain technology solution that we talk about, right? We'll have a view of that as well. We'll also look at how blockchain works, as what is the workflow typical blockchain will have altogether about, right? It will also help us to understand why it is being so robust and why all of the features that it brings to the table are so valuable. We'll probably get to understand that as well. And we'll also have a brief about what types of blockchains are there in existence as of now, right? So that's pretty much about the agenda. We'll start the session now. Blockchain, when it started, originally blockchain was kind of given a birth in the year 2008, right? There was a group, probably a person or a group of persons, who actually invented something which is now referred to as blockchain. So if you look at 2008, which was a turmoil going, the entire global economy was going through its own tremors. We had a subprime lending issue going through in the US, which actually forced all the world banks to go through financial crisis, if you remember. This also was a problem wherein decentralized, and that was kind of driving the entire economy in a very not so good shape. That's where this anonymous person or group of persons who are referred to as Satoshi Nakamoto, they actually invented something called blockchain, right? So their problem statement was, how can we do away from the centralized monopoly of banks or so-called financial institutions? How can we decide what should be the pure global currency which can really govern the entire economy, which can also help in stopping the hyper inflation in the economical world altogether, right? So that's how they invented blockchain. They first gestated and implemented the first blockchain database in the year 2008 as an infrastructure for the Bitcoin. Now, this is a new word for us, right? Probably we have heard of this word altogether. So Bitcoin, it was the first cryptocurrency ever created in the entire world, year 2008. So as of today, no one knows who Satoshi Nakamoto is or are as a group of people, right? So that still remains anonymous. Nobody knows as to who was the person, who were the people altogether who actually were behind inventing this shattering technology called blockchain and Bitcoin cryptocurrencies, right? So when these papers were published by Satoshi Nakamoto, so henceforth we refer to this person or group of people as Satoshi Nakamoto, since that has been the word coined by the entire world for this group of people who really invented blockchain and Bitcoin. Block and chain separately as two separate words or separate concepts altogether in the initial paper he or they published in year 2008 in the month of October. Later on, with time, because of so tightly coupling of the blocks and chains together, it became a single word called blockchain, right? So that's how it was invented, year 2008, when the entire world was going through economic turmoil. This was something new which was brought in by the person called Satoshi Nakamoto. So as they say, invention is the mother of necessity, right? So there was a necessity wherein we had an alternative approach to do away from the monopoly, or to have the challenge to the intermediaries or group of enterprises who actually play as intermediaries altogether. right? Moving to the next slide. How blockchain evolved. What was the evolution of blockchain, right? Blockchain 1.0. It was kind of publicized in the year 2008, as you rightly briefly discussed about. It was a simple ledger that recorded transactions. The purpose of this particular version of blockchain was just to record transactions in an as much as anonymous way or pseudonymous way. We'll touch base on what exactly it is. So the outcome of blockchain 1.0 version was nothing but the Bitcoin or all of the currencies that are there in today's world. Right. So the purpose of the big cryptocurrencies then was just to have a way, alternative way for people to trade, and that too in a very anonymous way as well as in a very secure way altogether. So that was about blockchain 1.0. Blockchain 2.0 was the next version or next wave, you can say, of blockchain, which also introduced, besides these simple ledgers or distributed ledgers, it also introduced smart contracts logic tier. So one of the classic examples of this blockchain 2.0 is Ethereum. Ethereum is another cryptocurrency. Now, Ethereum is just not a cryptocurrency, it is beyond a cryptocurrency. It's just not a cryptocurrency. It actually has an ability to build smart contracts. Now, what do you mean by smart contracts is your business logic or your terms and conditions which you want to get satisfied before you can pay to some vendor. You are actually buying some services or goods from a vendor, right? And you have some terms as to the quality of the goods, the quantity of the goods has to be as I had ordered, as you have ordered, right? So you check once you receive the goods, you check the quality of the goods, you check probably the wrapping of the goods, you check the quantity of the goods, and you say, yeah, you know what? All right, so the quantity is good, the quality is good, the packaging also was satisfactory to my satisfaction. All right, I think things are good. Here is the payment that I want to make to you to complete the transaction altogether. So that's something which is a contract or an agreement that you have with the person who's a vendor for you. Now, blockchain 2.0 introduces these smart contracts, which are an automatically executable contracts. Why you need to have a manual intervention? Why can't system decide based on some set of criteria as to the criteria that we made, the agreement has been in fulfillment, here is the payment that we have to make. That's what is smart contracts. We will of course look at the smart contracts subsequent slides more detailed or subsequent sessions. We will go through it more detailed way, but this is just brief about it, right? That's how 2.0 version of blockchain was, which introduced smart contracts as well. Blockchain 3.0, which is being very recently being introduced, brings something more than what it was to do with 2.0. Right? It actually introduced cloud-based services, multi-layer middleware, and it also introduced something called triplets. Just to give an example, Hyperledger Fabric, which is a consortium by the Linux Foundation, is a classic example of blockchain 3.0. So it has blockchain implementation in its own, which is also to do with 1.0 version fulfillments, version 2.0 fulfillments, and also something additional. So besides this blockchain 2.0 onward, it also has ability to deploy, to make blockchain setup architecture available over the cloud. It also introduced cloud services. Like IBM has its own cloud, which provides blockchain solution as a platform, or it's called a PaaS, platform as a service. Like Microsoft Azure also provides this blockchain platform on the cloud. It also introduced something called cryptlets. Now, cryptlets is again something which is tiny services which are provided by these setups, enterprise setups of blockchain services, which also provide specific APIs or event which you can capture and do whatever you want to do based on events. So cryptlets can be a variety of cryptlets. It can be a simple utility cryptlet to a contract cryptlet. There are various types of cryptlets. So that was something which was additionally introduced in blockchain 3.0, right? So Hyperledger classic example of 3.0. So one thing we should remember that smart contracts are unable to access internal data or events based on time or market condition. It cannot do that. Calling code or data outside of a smart contract or blockchain breaks the general trust barrier and authenticity of transaction. Similarly, cryptlets will allow the blockchain to access external data securely. code snippets which can help you to access external data to probably cater to your needs for your transaction to be completed or your smart contracts to be executed successfully. So it still makes sure that the integrity of the transaction on the blockchain is still maintained very well, allowing you to have an access to external data altogether, right? So that's very brief about how blockchain evolved from 1.0 to what it is 3.0 in today's world. Because it's essential for us to understand what is the making of blockchain, what is the premise of blockchain altogether before we move to the next session. All right, we'll move to the next slide now. So blockchain has been talked about. It's like a buzzword in the industry. Everyone, you go on the social networks, you go on any technical forums, you go to any of the RSS feeds, you will see at least 5 out of 8, 5 out of 10 blogs or contents are talking about blockchain altogether. It's being treated, it's being considered as the next gigantic wave after the internet. In year 2008, internet came in so with a boom, which changed the entire way of our day-to-day life, right? So blockchain is being considered as the next wave of the internet. So what's so disruptive about it? Why is it being treated as so disruptive? Well, there are some underlying characteristics of blockchain which actually make it the differentiator, which makes it so disruptive. We'll quickly go through those, right? First and foremost is security. So it is really impossible for anyone to tamper with transactions or ledger records present in blockchain. Now that's really important. That's really an important aspect of blockchain being secure, right? So it uses state-of-the-art world-class cryptography algorithms. For anyone to break these algorithms has to have million years of computing power to break the code logic, break the cryptography and all of that, which is just next to impossible in today's world. Right, so that's why it is so secure that you cannot simply change anything in the blockchain. Whatever records or transactions which are captured once on the blockchain cannot be changed. Right. Second thing that is important about it is its immutability. Right. So we'll of course subsequently slides we'll go through what is immutability, why it so differentiates blockchains from typical database. That's anyways being covered in subsequent slides though. So you can only write transactions to the blockchain. You cannot update or remove the transactions altogether. That makes it more secure, right? Second is its global reach. As I just mentioned, it's next way of internet. It's not concentrated on single geography. Like if you look at Bitcoin implementation of blockchain, there are miners across the globe who actually are using Bitcoin mining altogether. It's a global reach altogether. It's been universally accepted as a next disruptive technology way. Right? Blockchain has been adopted worldwide and has the backing of many investors from banking to non-banking sectors. There are so many consortiums being formed by existing software giants like IBM, Microsoft, Accenture, and whatnot. Right? That's why it has been unanimously accepted in today's world. Third most important part is automated operations. Now, this is really critical because if the system is automated, you are not expecting any manual intervention in the system. Right? Operations are completely automated through software. Private companies are not needed to handle operations on a day-to-day basis in a manual intervention way, which saves your effort. It also increases your accuracy operating, and all of that comes handy when it comes to automation. So no intermediary is required whatsoever be the case. I mean, if you look at the way, let's say, take an example of foreign exchanges, where we actually send money from, someone sends money from, say, some other country to India. So there is always an intermediary bank or an institution which actually takes care of settling down this transaction for you. Now, what if blockchain kind of solution, which automatically can look at the terms and conditions, execute those, if those are satisfied, can transfer the money to your bank accounts in India, and that's what we're talking about. That's all about automated operations. Far more granular level, we can touch base on this as to why it is so automated. We'll look at that again in subsequent. It's open source, which is really important, right? Blockchain is an open source technology. All the operations are carried out by the open source community. So whatever technology stack that is being used in building blockchain or the building blocks of blockchain are entirely open source, right? It is distributed. We look at what is distributed altogether as well. Blockchain works in a distributed mode in which records are stored in all nodes in the network. If one node goes down, it doesn't impact any other node. So it has its own scalability at its own, right? That's really important at the same time. And if you look at the ledger which is being used by blockchain is globally distributed ledger. So you are actually having the copies of transactions spread across the globe, which brings its own advantage altogether, right? It's flexible at the same time. So we touched base upon how it is open source based. Blockchain is programmable using basic programming concepts, which makes blockchain flexible. So it uses in today's world's most favorite open source technology stacks. It actually uses, if you want to write something in blockchain, you probably have to use a Solidity framework, Go language, you can use Java, you can use Node.js. All these languages are really open source and programmable altogether, highly programmable. That's another benefit of blockchain. There is not a black box in blockchain, yet it is secure, yet it is immutable, yet it. So that's the reason why blockchain became so popular, why it is so disruptive. It has huge potential to cater to today's world's heterogeneous problems that we have, challenges that we have in the world. All right. Again, we move to the next slide very quickly. Right. So we will spend a few minutes from now to understand how come blockchain is different than any typical traditional databases. Right. You can call blockchain as a database in its own, but it's not just a database, it's beyond a database, right? So what do we do? What do we see in traditional databases? What kind of operations we can perform in databases? Well, of course, we can do probably insert operations on databases, we can do some deletions, we can do some updations, like typically any application software that uses databases, based on the credentials of the user, it can, based on the roles assigned to the user, it can actually carry out insertion, updates, and then a deletion as well of the data, right? When it comes to blockchain, there is only insert operation. We briefly touched base on this in the previous slide, right? You cannot remove anything from blockchain. You cannot update anything existing on the blockchain. Once a transaction or data which is captured on blockchain is always there on the blockchain. Probably what you can do, if you want to make some changes to the data that you have captured on blockchain, you can go ahead, insert a new data set, which is referring to this previous one, which will be the latest version of it. Right? So the way version control works, in typical version control or source control software works, right? You make some changes to your program files and you want to update those, you probably are talking about the next version of the program files. You cannot make changes to the same existing version of the file and refer to it as the previous version. So you made some changes to a, let's say, a Java program which was versioned as 1.1. Now you are updating it with some additional changes. It will always be referred to as source control as 1.2. You cannot make it updated with same version of 1.1. That's what we are talking about as immutable blockchain, right? Replication. Traditional databases provide master-slave configurations. It provides also multi-master configurations where you can have multiple master databases taking care of replicating the data to its slave databases. Right? The typical master-slave configuration where you have one master database which is the golden copy for you, and second would be a slave database which is kept on updated based on the transaction structure, and then data goes from back and forth. When it comes to the blockchain, entire replication of the data of the blocks happens across every peer which is located globally some corner of the world. Now that's the beauty. If you want to, so it brings security as well in its own instance. So the data is replicated across all the peers just in time, in real-time manner. So that if you are making changes, someone tries to hack the data in a particular peer, the person, the entity has to replicate that hacking across all the peers. Well, you don't know where the peers are. You don't know how many peers are there which actually having captured this transaction, right? So that's the security that blockchain brings in handy. Consensus, another very important aspect that blockchain provides, right? So when it comes to traditional databases, how do you make sure that the transactions are conducted? If you remember the ACID properties of a typical transaction, right? ACID property, integrity and atomicity and all of that. you have something called two-phase commit or distributed transactions, which are captured over the distributed network or architecture, which is the feature that a typical database provides. When it comes to the blockchain, majority of peers agree on the outcome of transactions. So it's not just one entity or one database which actually decides, oh, this transaction is valid and I'm signing this transaction as a valid transaction. Good going. That's not the case with blockchain. It needs, by design, X number of peers or nodes which are having this replicated data with those have to approve, agree on the terms of the transaction. Then only transaction gets written on the blocks of the blockchain. That's really important for you, right? Next is invariance. So what do you mean by invariance is anybody can validate transactions across the network on blockchain. Well, you will see that that's really a threat to the data. When we look at how exactly blockchain operates, we'll touch base on this invariancy in detail. But any peer that actually captures the transaction published on the blockchain looks at some of the checksums of the transaction, and it, based on the transactions and the knobs that we call, it approves a valid transaction as a valid one, and then it publishes the transaction as good to go for writing to be written to the block. And when it comes to the traditional databases, we have integrity constants being in place. So we have rows being defined, we have realms, database realms, which also exist, right? So that also at times has a bottleneck on scenarios where we have high transaction flow coming into databases, and database actually chokes because of these constants being in place. So that's about a quick peek as to how blockchain differentiates from traditional databases. We also will look at some more details on this comparison. Right. So what are the characteristics that blockchain brings advantage on? Right. First and foremost is disintermediation. This is the reason. This was the prime reason why blockchain in year 2008 was introduced or innovated by Satoshi Nakamoto. Right. Disintermediation is something which is today's world's classic challenge, when we have intermediaries, persons or entities or enterprises or financial institutions which actually are taking us on a ride. They're actually playing a huge monopoly in being an intermediary. So blockchain brings advantage on removing or eliminating or reducing the footprints of the intermediaries by bringing smart contracts, automatic execution of the contracts, and all of that. Confidentiality. Of course, we will say that databases provide confidentiality. For example, you might want to encrypt the critical data of a transaction which is getting written to the database. Well, yes, but at the same time, someone can handle encryption as well. Someone has an access. Definitely, an administrator of the database has an access to the entire database. Can take it down, can decrypt the entire data, and voila, you have all the data being exposed. I mean, we have seen so many examples in today's world where the data critical information has been hacked. Sony Corporation had an issue where all its users' data was being hacked. There are so many examples we can talk about. So confidentiality, well, you never know when it comes to the database, but when it comes to blockchain, it's very tightly confidential, and no one can access. One thing, the way cryptography is being implemented. Second, the way transactions are being captured, with then consensus being in place, right? Robustness, right? Now, when it comes to databases, robustness in terms of scalability, availability, and maintainability, there is still manual information needed. When it comes to blockchains, it's again automated process wherein if one peer goes down, the programs or the blockchain technology is so smartly written that it can actually eliminate that peer for a moment, heal that peer to get it updated and bring it back on the network. This all is done automatically without any manual intervention, right? One peer goes down, forget it. We are globally present, right? So that's the benefit that blockchain brings in. Performance, well, there is some lacuna or an arguable pitfall of blockchain, the way it is being designed. When it comes to performance of transactions, centralized databases bring an advantage wherein the transactions are being centrally are being reciprocated on multiple databases in real time, primarily because the transactions are true. There is no need for blockchain, because of the consensus is mandatory for any transaction to be captured on databases. It becomes essential that all the consensus from different peers is been acquired before the transaction gets locked or committed to the blockchain database. That's where we might see some issue in terms of the time lag of 10 seconds or so for the transaction to be completed, captured, right? Next is history of itself or audit trails. When it comes to databases, standard databases, the audit trails have to be manually captured, or there has to be a separate or explicit mechanism to be established to capture the audit trails. Well, there is still no guarantee that you will have foolproof audit trails being captured by traditional databases. But when it comes to blockchain, the audit trail is maintained right from the beginning of the blockchain. The first block, which is called the Genesis block, right from there, each and every transaction, each and every minute detail is being captured on the blockchain itself. So audit trail is maintained by self at its own by default, right? Blockchain do have strong use cases where disintermediation and robustness are more important than confidentiality and performance. So it might be okay for a particular specific business case wherein we are not having any challenge with the performance, but we want to make sure that robustness, disintermediation, and the security is the paramount objective. Blockchain comes very handy over there. All right, we move to the next session, which is distributed ledger technology, or the DLT as an acronym for it. So people often think of blockchain technology as distributed ledger technology, as one and the same rather, right? Well, interestingly, it's not the case. So let's briefly go through what exactly distributed ledger technology, or we will refer to it as DLT, is, how it is different than blockchain. Right, so we'll go through what exactly it is, right? So a quick peek as to how blockchain and distributed ledger are two different things altogether. Blockchain primarily focuses on how data is stored and linked to one another in a chronological manner within blocks, right? That's why blockchain altogether being the word. So it actually talks about ordering the data, interlinking the data to each other, and putting it in the right manner onto the blocks. Whereas distributed ledger focuses on sharing of the database amongst all the operational participants of the network. So whatever we have written on the blocks in a blockchain in a chronological manner, so once the block actually captures the transaction, validates the transaction by different peers, validated transactions are being captured on blockchain, and then they are reordered in a chronological manner. After that, distributed ledger takes care of sharing this entire version of the blockchain or the world state of the blockchain across all the peers over the global network. That's the differentiation between blockchain and distributed ledger primarily. Blockchain is a sequence of blocks which are connected by that's how it forms the chain of blocks, right? Distributed ledger does not require such chain as it's entire state of data altogether being together, right? Blockchain requires consensus algorithms. We talked about this very briefly in previous slides, wherein different peers have to arrive to a consensus on the validity of a particular transaction which is being captured on the blockchain. So blockchain has to have consensus algorithms being running on the peers, make sure that the transactions are valid and are in the valid state of affairs, right? Well, in case of distributed ledger or DLT, consensus algorithm is not really required, because the purpose of DLT is not to arrive at a consensus. It just captures the state of the blockchain altogether, right? Blockchain cannot be easily scalable. Primary reason we talked about is the way algorithms execute. X number of peers have to approve the transaction for its validity, then it can move. This DLT theoretically offers better scaling options, right? And we will touch base on why theoretically. So the key is all blockchains, of course, are distributed ledgers, but not all distributed ledgers are blockchain. That's important for us to know.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.